Going forward, we will be working with configurations in YAML file. So it is important that you are comfortable with YAML. Let's recap a few things real quick. Of course, we first learned how to run a Docker container using the docker run command. If we needed to set up a complex application running multiple services, a better way to do it is to use Docker Compose. With Docker Compose, we could create a configuration file in YAML format called dockercompose.yaml and put together the different services and the options specific to to running them in this file. Then we could simply run a Docker Compose up command to bring up the entire application stack. This is easier to implement, run, and maintain as all changes are always stored in the Docker Compose configuration file. However, this is all only applicable to running containers on a single Docker host. And for now, don't worry about the YAML file. We will take a closer look at the YAML file in a bit and see how to put it together. That was a really simple application that I put together. Let us look at a better example. I'm going to use the same sample application that everyone uses to demonstrate Docker. It's a simple yet comprehensive application developed by Docker to demonstrate the various features available in running an application stack on Docker. So let's first get familiarized with the application, because we will be working with the same application in different sections through the rest of this course. This is a sample voting application which provides an interface for a user to vote and another interface to show the results. The application consists of various components such as the voting app, which is a web application developed in Python to provide the user with an interface to choose between two options, a cat and a dog. When you make a selection, the vote is stored in Redis. For those of you who are new to Redis, Redis in this case serves as a database in memory. This vote is then processed by the worker, which is an application written in .NET. The worker application takes the new vote and updates the persistent database, which is a PostgreSQL in our case. The PostgreSQL simply has a table with the number of votes for each category, cats and dogs. In this case, it increments the number of votes for cats as our vote was for cats. Finally, the result of the vote is displayed in a web interface, which is another web application developed in Node.js. This resulting application reads the count of votes from the PostgreSQL database and displays it to the user. So that is the architecture and data flow of this simple voting application stack. As you can see, this sample application is built with a combination of different services, different development tools, and multiple different development platforms such as Python, Node.js, .NET, etc. This sample application will be used to showcase how easy it is to set up an entire application stack consisting of diverse components in Docker. Let us keep aside Docker Swarm, services, and stacks for a minute and see how we can put together this application stack on a single Docker engine using first Docker run commands and then Docker Compose. Let us assume that all images of applications are already built and are available on Docker repository. Let us start with the data layer. First, we run the Docker run command to start an instance of Redis by running the docker run Redis command. We will add the -d parameter to run this container in the background, and we will also name the container Redis. Now, naming the containers is important. Why is that important? Hold that thought. We will come to that in a bit. Next, we will deploy the PostgreSQL database by running the docker run Postgres command. This time too, we will add the -d option to run this in the background and name this container db for database. Next, we will start with the application services. We will deploy a front-end app for voting interface by running an instance of voting app image. run the docker run command and name the instance vote. Since this is a web server, it has a web UI instance running on port 80. We will publish that port to 5000 on the host system so we can access it from a browser. Next, we will deploy the result web application that shows the results to the user. For this, we deploy a container using the result-app image and publish port 80 to port 5001 on the host. This way, we can access the web UI of the resulting app on a browser. Finally, we deploy the worker by running an instance of the worker image. Okay, now this is all good, and we can see that all the instances are running on the host. But there is some problem. It just does not seem to work. The problem is that we have successfully run all the different containers, but we haven't actually linked them together. As in, we haven't told the voting web application to use this particular Redis instance. There could be multiple Redis instances running. We haven't told the worker and the resulting app to use this particular PostgreSQL database that we ran. So how do we do that? That is where we use links. Link is a command line option which can be used to link two containers together. For example, the voting app web service is dependent on the Redis service. When the web server starts, as you can see in this piece of code on the web server, it looks for a Redis service running on host Redis. But the voting app container cannot resolve a host by the name Redis. To make the voting app aware of the Redis service, we add a link option while running the voting app container to link it to the Redis container, adding a -- link option to the docker run command and specifying the name of the Redis container, which in this case is Redis, followed by a colon and the name of the host that the voting app is looking for, which is also Redis in this case. Remember that this is why we named the container when we ran it the first time, so we could use its name while creating a link. What this is in fact doing is it creates an entry into the etc host file on the voting app container, adding an entry with the host named Redis with the internal IP of the Redis container. Similarly, we add a link for the result app to communicate with the database by adding a link option to refer the database by the name DB. As you can see in this source code of the application, it makes an attempt to connect to a Postgres database on host DB. Finally, the worker application requires access to both the Redis as well as the Postgres database. So we add two links to the worker application, one link to link the Redis and the other link to link Postgres database. Note that using links this way is deprecated and the support may be removed in future in Docker. This is because, as we will see in some time, advanced and newer concepts in Docker Swarm and networking supports better ways of achieving what we just did here with links. But I wanted to mention it anyway so you learn the concept from the very basics. Once we have the Docker run commands tested and ready, it is easy to generate a Docker compose file from it. We start by creating a dictionary of container names. We will use the same name we used in the Docker run commands. So we take all the names and create a key with each of them. Then under each item, we specify which image to use. The key is the image and the value is the name of the image to use. Next, inspect the commands and see what are the other options used. We published ports, so let's move those ports under the respective containers. So we create a property called ports and list all the ports that you would like to publish under that. Finally, we are left with links. So whichever container requires a link, create a property under it called links and provide an array of links such as Redis or DB. Note that you could also specify the name of the link this way without the semicolon and the target name. And it will create a link with the same name as the target name. Specifying the DB:DB is similar to simply specifying DB. We will assume the same value to create a link. Now that we're all done with our Docker Compose file, bringing up the stack is really simple. Run the Docker Compose up command to bring up the entire application stack. When we looked at the example of the sample voting application, we assumed that all images are already built. Out of the 5 different components, 2 of them, Redis and Postgres images, we know are already available on Docker Hub. They are official images from Redis and Postgres. But the remaining 3 are our own application. It is not necessary that they are already built and available in a Docker registry. If we would like to instruct Docker Compose to run a Docker build instead of trying to pull an image, we could replace the image line with a build line and specify the location of a directory which contains the application code and a Docker file with instructions to build the Docker image. In this example, for the voting app, I have all the application code in a folder named vote, which contains all application code and a Docker file. This time, when you run the Docker Compose up command, it will first build the images, give a temporary name for it, and then use those images to run containers using the options you specified before. Similarly, use build option to build the 2 other services from the respective folders. We will now look at different versions of Docker Compose file. This is important because you might see Docker Compose files in different formats at different places and wonder why some look different. Docker Compose evolved over time and now supports a lot more options than it did in the beginning. For example, this is the trimmed down version of the Docker Compose file we used earlier. This is in fact the original version of Docker Compose file known as version 1. This had a number of limitations. For example, if you wanted to deploy containers on a different network other than the default bridge network, there was no way of specifying that in this version of the file. Also, say you have a dependency or startup order of some kind. For example, your database container must come up first and only then should the voting application be started. There was no way you could specify that in the version 1 of the Docker Compose file. Support for these came in version 2. With version 2 and up, the format of the file also changed a little bit. You no longer specify your stack information directly as you did before. It is all encapsulated in a services section. So create a property called services in the root of the file and then move all the services underneath that. You will still use the same Docker Compose up command to bring up your application stack. But how does Docker Compose know what version of the file you're using? You're free to use version 1 or version 2 depending on your needs. So how does the Docker Compose know what format you are using? For version 2 and up, you must specify the version of Docker Compose file you're intending to use by specifying the version at the top of the file. In this case, version:2. Another difference is with networking. In version 1, Docker Compose attaches all the containers it runs to the default bridged network, and then use links to enable communication between the containers as we did before. With version 2, Docker Compose automatically creates a dedicated bridged network for this application and then attaches all containers to that new network. All containers are then able to communicate to each other using each other's service name. So you basically don't need to use links in version 2 of Docker Compose. You can simply get rid of all the links you mentioned in version 1 when you convert a file from version 1 to version 2. And finally, version 2 also introduces a depends on feature. If you wish to specify a startup order, for instance, say the voting web application is dependent on the Redis service. So you need to ensure that Redis container is started first and only then the voting web application must be started. We could add a depends on property to the voting application and indicate that it is dependent on Redis. Then comes version 3, which is the latest as of today. Version 3 is similar to version 2 in the structure, meaning it has a version specification at the top and a services section under which you put all your services, just like in version 2. Make sure to specify the version number as 3 at the top. Version 3 comes with support for Docker Swarm, which we will see later on. There are some options that were removed and added. To see details on those, you could refer to the documentation section using the link in the reference page following this lecture. We will see version 3 in much detail later when we discuss about Docker stacks. Let us talk about networks in Docker Compose. Getting back to our application, so far we have been just deploying all containers on the default bridged network. Let us say we modify the architecture a little bit to contain the traffic from the different sources. For example, we would like to separate the user-generated traffic from the application's internal traffic. So we create a front-end network dedicated for traffic from users and a backend network dedicated for traffic within the application. We then connect the user-facing applications, which are the voting app and the result app, to the front-end network, and all the components to an internal backend network. So back in our Docker Compose file, note that I have actually stripped out the port section for simplicity's sake. They're still there, but they're just not shown here. The first thing we need to do if we were to use networks is to define the networks we are going to use. In our case, we have two networks, front-end and back-end. So create a new property called networks at the root level adjacent to the services in the Docker Compose file and add a map of networks we are planning to use. Then, under each service, create a networks property and provide a list of networks that service must be attached to. In case of Redis and DB, it's only the backend network. In case of the front-end applications, such as the voting app and the result app, they're required to be attached to both a front-end and backend network. You must also add a section for worker container to be added to the backend network. I have just omitted that in this slide due to space constraints. Now that you have seen Docker Compose files, head over to the coding exercises and practice developing some Docker Compose files.
Hello and welcome to this demo. In this demo, we're going to look at the example voting app. The example voting app is available in GitHub under the Docker samples repository, and it is available at example-voting app. I will add a link to this in the resources section. In this demo, we're going to look at the architecture of this. We're going to look at the source code a little bit, understand how it's put together, and we will try and deploy this application using Docker. But to start with, we're just going to deploy this application with Docker run, just to make it really simple. And then in the next demos, we'll try to use Docker Compose, and going forward, we'll use Docker Stack and services to deploy it on Swarm. So as a first step, let's try and just understand the application. So the source code is available on GitHub, and you can see basic documentation here. If you look at the architecture, as we discussed in the lecture, you have a voting app which is based in Python, and then you have a Redis messaging system. The vote is cast and it goes to the worker, which is based on .NET, and then the vote is updated in a Postgres database, and then finally the result is displayed in a Node.js based result web application. Out of these, two of the components are Redis and Postgres, so we don't have to worry about that. The three other components are the applications that we develop. So there are three folders in this code repository. We'll first look at the voting app. So if you click on the vote directory, you will be able to see the source code of it, and it's a Python based application. So you have the app.py with the Python code in it. If you open the Python code, it's a Flask based application. It's a very simple application. It has a post and a get request. The get request sends an index.html which shows the actual web page where a user can cast a vote, and when the user casts a vote, it comes to this post section, and that is where it establishes a connectivity to Redis and tries to store the vote information in Redis. So that's all that this particular voting application is, one thing to take note here is the host that it tries to connect to. It tries to connect to a host named Redis. Okay, now alongside the code we also have the Docker file. So it creates it from a Python 2.7 Alpine image, and then sets the working directory to app, installs the Python requirements, and the next step is where it copies the application code into the app folder, and finally the entry point for the application. Next we will take a look at the worker. So go to the worker folder, and the source code of the application is under the main Java worker folder, and there's a worker.java. If you look at this code, this is a .NET based application. So at the top it tries to connect to the Redis and the Postgres database, and there's a while loop where it waits for the votes from Redis, and whenever a vote is cast and is available in Redis, it takes that vote and updates the table in the Postgres database. If you're interested, go through and take a look at the remainder of the code. We will then look at the Docker file. So the Docker file is based on Microsoft.NET SDK, and that is where it adds the source code of the application to the worker folder, and finally updates the command required to start the worker. Next we will look at the resulting app, which is based in Node.js. So that is under the result folder, and open the server.js. This is an Express based server, and you can see the source code for that. And all this does is it establishes a connectivity to the Postgres database, and as you can see, the Postgres database that it hosts, that it tries to connect to, is DB. So that's the host name that it tries to connect to, and then it reads the database and reads the values from the database and displays that on the UI. And if you look at the Docker file for that, it starts from the Docker image, starts from a Node.js slim image, and then adds the package.json, which has the dependencies, runs npm install to install those dependencies, copies the source code over, and finally specifies the node server.js command that is to be run when the application starts. And then there are also in the source code repository, there are also some Docker Compose and Docker Stack files, but we will not look at that right now. We will be creating those ourselves, so we will just ignore that. So what we're going to do now is we'll just go and try and deploy this application ourselves with Docker. But the first thing that we need to do is build these images, because we know that the Redis and Postgres databases already have images available on Docker Hub, but the three others are the applications that we are developing, so we do not have images built for those, so we'll have to build them. So I'm going to first clone the source code repository to my local system. So I will do a git clone and then paste the address, and that will clone the source. It is cloned into example voting app, and when I go into example voting app, I have all the code that we just walked through. Okay, so we will start with deploying the voting app. For that, we need to create a Docker image for the voting app. So we will go into the vote directory, and we look at the Docker file. The Docker file looks intact. So we're just going to go ahead and build the Docker image by running the docker build command, and we will tag it with the name voting-app. Okay, so the Docker image is built. If you run the Docker images command, you can see that it has the voting-app image built. So now that I have the voting app image built, I can run a container by running the docker run voting app command, and I'm going to publish a port 5000 to 80. So the container, the voting app container runs on port 80, and I'm going to map that to port 5000 on my host so that I can access it from a browser. So it looks like the container is running. So I'm going to try and open a browser and go to the address with port 5000, and I can see that the web application is displayed, and I can see two options to cast my votes, cats and dogs. Now if I try to cast a vote by clicking on one of the button, you can see it tries to it takes a while, and after a while it fails, and I can now see that there's an internal server error. It says the server encountered an internal error and was unable to complete your request. If I go back and look at the logs, I see that it's failed at the line redis.rpush. So basically it's unable to establish a connectivity to the Redis, obviously because we haven't run a Redis instance. So what we're going to do now is I'm just going to kill that instance, and I will first start a Redis container. So I will run an instance of Redis, and I will name it Redis. So it's pulling down the Redis image, and it's run an instance of Redis. I forgot to run it in the background, so I'll stop that and run it again with the -d for detached option. Okay, so when I tried that, it failed again because I had already run it in the without the detached option. So it already created a container with the name Redis, and I'm trying to create another container with the same name, so it's preventing me from doing that. So I'll have to delete the previously created container. So I'm going to run a docker rm command to delete the previously created container, and I'll run the same command again to start a new instance of Redis. So I now have a Redis instance running. I'm now going to start an instance of my voting app. So I will run the docker run command with the voting app, and I will publish the port 5000. I will also this time add a link to the Redis server. So I'm running a voting app, and I've added a link using the -- link option, and I've specified Redis as we discussed in the lecture. Okay, so it's running now. I'm back to my web portal, and when I try to cast a vote, you see that it goes successfully, and I get a tick mark back. Now this is because my container was now able to establish a connectivity to Redis. So now we have successfully deployed a Redis as well as the voting application. We will now proceed to the worker. And for the worker, a prerequisite is to have a Postgres database. So we will first deploy a Postgres database instance. I'm not very sure what is the version of Postgres that this application requires. So I'm going to go into one of the files here. For example, if I go into the Docker stack file or a Docker compose file, I should be able to find the image that they used. So it's image 9.4. So I'm just going to use that here. I will name the instance DB, and so later on I can use that to create a link. And now, as you can see, it's running. The Postgres database is now started and it's running successfully. I forgot to run it in the background, so I'm just going to kill that, run it in the background. Okay, I hit the issue again about the duplicate name, so I'm just going to delete the one that I created using the docker rm command, and I'm going to rerun the Postgres database in the detached mode. So I now have the Postgres database running. So if I do a docker ps, I see that there are 3 containers running. One is my voting app, one is my Redis, and the third one is the Postgres database. I can now go ahead and deploy the worker. So first I'll have to build the worker. So if I go to the worker directory, I can see the contents of the Docker file, make sure it's intact, and I'm going to run the docker build command to create and to build the Docker image for the worker, and we'll just wait for that to finish. Once that is finished, when we run the docker images command, we are able to see all the images that are available and our newly created worker app image. We will now run an instance of the worker app. Now the worker app needs 2 links. One is to the Redis and another link to the Postgres database. Okay, so it runs, and as soon as it runs, you can see that it's processed 1 vote. So that is the vote that we casted earlier. Okay, so now when I run the docker ps command, I can see that there are 4 containers running. So we have the worker app ready. The next step is to build and deploy the resulting app. So that's the last step. So we will create an image for the result app. We will deploy it and link it to the Postgres database. So we go into the code repository for result, and I have all the application and Docker files there. I will make sure the Docker file is intact, and then I'm going to run the docker build command to create an image for this result app, and I will tag it result-app. So it goes through all the Node.js related installation steps, and finally it's completed. So now I have a new image, which is the result app. I'm now going to run the result app, but it has since it is a web server, it has a port requirement. So it exposes port 80, and that's where it listens. So I'm going to map port 80 to port 5001 because port 5000 on my local host is already occupied by the voting app. So my result app, I'd like to see it on port 5001. So I'll publish the port 80 to 5001, and I also need to add a link because the result app is linked to the DB. So I'll add a link for that. Okay, so that should be it, and I'm now going to hit enter, and I can see that the application has started and it's connected to DB, which is good. And if I go to the web browser and establish a connectivity to port 5001, and I can see the result page. So this is the result page. Since my vote was for cats, I see the 100% votes for cats. I could also go back and change my vote. So if I go back and change my vote to dogs, I see it's changed immediately. So every time I change my vote, it goes through the full cycle. The data goes through Redis, the worker processes it, updates the database, and then it's finally shown in this result page. So that's it for this demo. We took a look at the example voting app. We understood the architecture of it, how it works, and we also successfully deployed it with Docker run commands using links. Hello and welcome to this demo. In this demo, we are going to look at Docker Compose. So we're going to look at how to use Docker Compose to deploy a complex application stack. We're going to use the same example voting application, and we will try and deploy it with Docker Compose. First and foremost, Docker Compose does not get installed by default. When you install Docker on a host, you need to install it separately. So instructions for installing Docker Compose can be found on the Docker documentation site. There are instructions for installing Docker on Mac, Windows, and Linux. And since I'm on Linux, I'm going to follow the instructions in the Linux section. So Docker Compose is simply a script that needs to be run. So all you need to do is use curl and download the Docker Compose file. And once it's downloaded, you set executable permissions to that file, and that should be it. You should have Docker Compose ready to go. Okay, so we have Docker Compose installed. What we're going to look at is first, in the previous demo, we had everything running. So now we're going to first clean up. So we're going to stop all the running containers. So you could run the docker stop command and specify the first 2 digits of all the containers, and it will stop all those containers at once. We can now run the docker ps command to ensure that there are no more containers running. We will now create a Docker Compose file. So we will create a docker compose.yaml file. And the first thing that we'll do is we'll simply start by defining services. So that is what you should do when you start working on a Docker Compose file. Identify all the services required and list them as root properties in the file. So if you look at our architecture diagram, we have a Redis, database, voting app, worker, and result. So I'm going to create an entry for each of them. The first one being Redis. Second one is DB for Postgres database. Third one is vote for voting app. Then worker for worker app, and result for the result app. Okay, now I'm going to edit that file, and I will now add the image specifications. So I will specify the image that should be used to deploy each of these services. Redis uses Redis image, DB uses Postgres database image with a tag of 9.4, Vote uses voting app. I've already built the voting app as part of our previous demo, so I'm just going to reuse that. Worker uses worker app, and result uses result app. So that is good. Next, we need to update port mappings. So I'm going to create a ports property, and under that I'm going to add a list. So the list should be defined using a dash or a hyphen. For the voting app, I'm going to publish port 80 to 5000, and for the result app, I'm going to publish port 80 to 5001, just like what we did in the previous demo. And so there's just one more thing pending, which is the links. So I'm going to add a property for links, and I'm going to link the voting app to Redis, the worker app to Redis and database, and the result app to Postgres database. Okay, so I'm all set. I'm going to save that file, and then I'm going to run the docker compose up command. Okay, so running the docker compose up command now will create all the containers. As you can see, the containers are created with a name, with a prefix root. That is because the current directory that we are in is with the name root. So whichever directory you are in, it uses that directory and prefixes the container names with that directory. As you can see, it's kicked off all the different containers, and all of them are up and running, and I'm now able to access the voting and app and the result page, and I'm able to cast a vote, and I'm able to see the result in the results page.
In this demo, we will take a look at improving our Docker Compose file. In the previous demo, we saw a very basic version of Compose file. It's the older original version, that's version 1 of the Docker Compose file, which is much simpler but does not support many advanced features. So we will upgrade it to version 3. So go to Docker documentation pages and look at the Compose file section. We see the different versions of Docker Compose, from which we will select version 3. And as you can see here, to convert an existing Docker Compose file to version 3, we simply need to specify the version at the top of the file and then move all of our current items in the file, whatever we have created, under a section called services. So in the Docker, back to my Docker Compose file, I will specify the version at the top and give it the version number. We can just say version 3. And then add a section called services below that. And then we move everything we already have under it by selecting all the lines and hitting a tab. So if you're using an editor that supports YAML like VS Code, which I'm using, then this works. So now we have this file ready. With version 3, when you deploy the application with a Docker Compose file like this, it will automatically create a network for these containers and connect all containers to that network, or all services that we have specified in this file to that particular network. And that network also takes care of DNS resolution. So all containers within this application will be able to reach each other using the service names that are given here. For example, the Vote app will be able to reach the Redis or DB app with the host name Redis or DB. So we no longer need the links section that we have manually specified. So we can get rid of all of those first. So I will go ahead and remove the links section wherever I've mentioned. So this is now a simple valid version 3 of Docker Compose file. Let us now deploy this using the Docker Compose up command and wait for all the services to be deployed. So currently my Docker Compose file is in a directory named code. So Docker Compose will use that as your project name. So whichever directory you are in is the name of that project, and all objects created by this Docker Compose up command will have this project name prefixed to it, as you can see here. As you can see, the network it creates is named code_default, and the services it creates are named code_worker, code_redis, etc. You can of course give a custom project name using a command line property. Now the services are being deployed, but we see that there is an error that says no such device or address and waiting for DB. So this indicates that the worker and result app are not able to reach the database. We know that the worker and result app relies on the Postgres database. If you scroll up, you see an error reported by PostgreSDB database. It says that we must specify a default password for the database using the Postgres_password environment variable. So this was a recent change in the Postgres database image that makes it necessary to specify a default superuser password. As such, the database is not initialized, and that's why we saw the error, because the other services were not able to access the database. To fix this, we specify the environment variable Postgres_password under the DB container. The worker app and result app are all hard-coded to use Postgres as the username and password to connect to the database container. So it's important that we specify the same password and username for the Postgres database. So once set, we bring it up again using the Docker Compose up command, and this time we see that everything is up. So I'll now access the voting app and result app and test the setup. We can use localhost port 5000 to access the voting app and port 5001 to access the result app. So first I cast a vote for cats, and we see that cats are 100% in the result page. And then if I change the vote for dogs, I see that dogs is now 100%. So that confirms the setup is working.